Thank you, Jonas, and welcome everyone.
Did I do that
It's
when
a
I plugged
great,
in?
great pleasure to introduce Diane Olson Belanger. She's a dedicated public historian and author.
Oops.
She is an active and inspiring leader with the American Association of University Women for many, many years. In addition, she's been a volunteer docent at Smithsonian Museums, where she brings insight and meaning to many aspects of American history. Today, we'll hear firsthand about one of her very unique adventures in bringing history to light. So bundle up and enjoy. And Diane, thank you for being with us. Take it away.
Get rid of this.
There we go.
Sorry, I was not able to see anybody. Is it my turn?
Yes, it is. Yeah. Yeah.
Okay. Let me... I'm supposed to have a shared screen here.
What happens when you click on share screen?
That's what I just did 3 times.
Tell the host yes, allow you to share. There it is. Click on your Antarctica one.
Okay, now I need to do the slideshow. Oh, wait a minute. Okay, ready to go? All right. Well, I'm sorry about all that. I don't know what happened. I can't hear any of you, but thank you, Lorna, for having me. Thank you, Jonas, for trying to make it go. Let me just say that I'm so pleased to be here to talk about Antarctica and the International Geophysical Year. For me, the story is one of pioneering, path-breaking scientific successes, bookended by 2 political miracles. The first is that it happened at all because of the Cold War, and the second miracle in my mind is that because of the Antarctic Treaty, that the IGY in Antarctica never ended. So let's see. So my professional credential for speaking with you today is the book that I was privileged to write with a grant from the National Science Foundation, which runs the US Antarctic program today. And the book is called Deep Freeze, and I think you'll realize why shortly. And my personal credential is that I was able to go to Antarctica thanks to the National Science Foundation, and even to the South Pole itself. So a little history. You know, nobody knew what was at the bottom of the Earth, if anything, until there was a lot of speculation about that, of course, but between 1772 and 1775, British Captain James Cook circumnavigated the entire polar continent, but he never got close enough to see it. However, he got close enough to encounter dangerous icebergs and horrible weather, and he just said it was so terrible no one would ever go there again. Unfortunately, he also reported that the sub-Antarctic islands were teeming with fur seals. Well, that was a very valuable commodity at the time, and plenty of entrepreneurs were willing to risk all of those conditions to go after them. And indeed, in the space of about a generation, that fur seal population was just about decimated. But toward the end of that time, in the early part of the 19th century, because of all of that economic... 19th century. Sorry, I've got a coach here. At the early years of the 19th century, because of all of the activity in fur sealing and whaling and so on, 4 different countries sent naval expeditions to the polar south, I think to see what was in it for them and to, wave their respective flags. One of those was an American expedition led by Lieutenant Charles Wilkes. This was between 1838 and 1842. And he sailed far enough around the polar continent and close enough to it that he decided, he recognized it as a continent. And it was Wilkes who named it Antarctica, basically the opposite of the Arctic. By any account, he was a terrible leader. Everybody hated him, but he was a scientist, and he brought scientists along whose published studies are respected today. But then after about the 1840s, for another half century, Antarctica slept pretty much undisturbed. Until there was an International Geophysical Congress in London in 1895. And the takeaway from that was we just have to learn more about the polar continent, that last place on Earth. And that ushered in what we call today the heroic era, which lasted until about World War I. And I guess that era is epitomized by what we're looking at here. This is British Captain Robert Falcon Scott arriving at the South Pole, only to realize that he's been beaten because he's greeted by the Norwegian flag, which has been raised there a month earlier by Roald Amundsen. So this photograph was taken on January 17th, 1912. None of the heroic era expeditions were led by Americans, but between the 2 world wars, American explorers dominated Antarctic exploration, and among those, the dominant figure was Richard E. Byrd. He had his first expedition beginning in 1928, and he either led or his name was used on 5 total expeditions, the last of which was during the setting up of the IGY. When we have to take a side story here because of its importance, during the first half of the 20th century, 7 different countries proclaimed that they owned pie-shaped sectors of the polar continent. All of those countries were friendly to the United States, but it was rather peculiar. You may have seen a map that looked like this. I know I did as a kid, and it confused me so much I didn't want to look again. But to name the country's claims. So if you can follow my line here, that first claim is that of Chile. Followed around clockwise is in blue the claim of Argentina, and surrounding almost all of that is the claim of the British, the United Kingdom. Well, that doesn't make any sense that 3 countries can claim the same territory in a faraway place. And each of them was always complaining that the other 2 were trespassing on their sovereign territory. And indeed, at least once, that hard feeling ended in gunfire. So that's kind of an unsustainable thing. But moving around, then we have the claim of Norway. But the Norwegians, for whatever reason, never established a northern or southern boundary on their claims. So that's why it's a little bit mushy there. And then there is a huge claim of Australia, and it is just south of the Australian continent. But it is bisected by this skinny little sector claimed by France. At the top of the map here is the Ross dependency of New Zealand, their claim, and again, south of New Zealand. But then at the end, there is this small sector that no one officially claimed, although it was unofficially often called the American sector because that's where Byrd and other Americans did much of their work. But the government never acted on it, much to some concern. So keep that in mind because it will factor later. So the IGY got its start at a small dinner party at the home of James Van Allen, a famous and important American scientist. And on April 5th, 1950, he at the time was working at the Applied Physics Laboratory of Johns Hopkins University, then in Silver Spring. And he was visited there by Sidney Chapman at the top here, a world famous British geophysicist. And they were having a fine time, and Van Allen asked him to dinner, along with a small handful of American scientists of repute, including Lloyd Berkner, shown here on the right. And at some point during that rather mellowed evening, Berkner turns to Chapman and says, "Sidney, don't you think it's time for another international polar year?" And Chapman right away said, "What a great idea. Let's do it." And they did. They're talking about organizing an international effort and had absolutely no doubt that they could pull something like that off. They were scientists, and science was said to have won the war. Think about radar and the proximity fuse or the atomic bomb. All of those were scientific contributions to that. So it was mostly Chapman who took the idea of a third international polar year to the scientific community internationally, basically the National Academies of Science by whatever name from all over. And everybody was very excited about this. You know, yes, let's do it. But eventually the World Meteorological Organization sent representatives, and they agreed this was a wonderful idea. But they basically said, "You guys are thinking too small. We think we should study the entire planet." And so what began as a third international polar year morphs into the International Geophysical Year. This was after two previous polar years, the first one in 1882-83, pretty ambitious effort. And there was a second in 1932-33. These are all scientific efforts cooperatively done. The second one really was truncated badly by the Great Depression, but Byrd timed his second expedition to coincide with this, for mutual benefit. But this new IGY now is going to be planned and coordinated internationally by the scientists who are politically savvy enough to keep everything about the IGY apolitical, meaning anybody can participate regardless of their politics. And they further decided that the participating countries would establish their own programs of study. So in the United States, we had our US National Committee for the IGY, which was to be housed and operated through the National Academy of Sciences. So the IGY now is going to be a cooperative effort to study globally the Earth and its environment. And after all this planning is done, and everything including search and rescue has been pretty well decided, then the national committees who would plan their own programs according to their own means and interests, then they had to go back to their respective governments to ask for the money to pay for this, because it was going to cost a lot. So the American scientists went to Congress and asked for money, and Congress wasn't so sure until the leaders very astutely reminded them that, well, the Soviet Union is planning a very large, very ambitious program. And well, all of a sudden, how much do you want? So, and eventually the Congress was pretty happy about the whole thing. The wrinkle there was that Congress could not supply money to the National Academy because it was not a government agency. And so the National Science Foundation became the banker for the IGY. And the NSF had just been founded in 1950. So this was an incredibly big boost to their budget as well as their responsibilities. I had to make this montage just to remind us of how big a deal the IGY was in the 1950s. The news coverage was incredible. The New York Times had a full-time senior reporter just working on the IGY. So to sum it up, this International Geophysical Year actually was to be an 18-month year running from July 1, 1957 through the end of 1958. And in the end, 66 countries participated in this global, cooperative, collaborative, simultaneous, identical effort to study the Earth and its environment. 12 of those countries would send scientists to Antarctica at their own national bases. And Antarctica, we have to remind ourselves, at the time was still one of the two great unknowns. Of course, the other was outer space, and think Sputnik. We know that it was launched in October of 1957, but very few people today have any clue that it was the achievement of an IGY goal. One, of course, that the United States hoped to do first, but didn't happen that way. Oh, yes. And we must remind ourselves that this is all taking place in the depths of the Cold War. We are now having two superpowers, both of whom have not only the atomic bomb, but the hydrogen bomb. The Earth is teetering on the edge of a nuclear abyss. And somehow, the IGY made it possible to step back from that a bit. And I call that a political miracle. So those 12 countries then had their respective science stations in Antarctica. First of all, I wanted to say there were about 6 of them altogether. Notice that all 7 of the claimant countries have, well, many of them were already there, but they are going to be participating. Belgium and Japan were actually returning to Antarctica, or the ice, as everybody calls it, who's part of it, because they had expeditions during the heroic era as well. South Africa gets in because it's sort of a South Hemisphere neighbor, and it had a few offshore bases for science. And then the biggest programs were the United States and the Soviet Union. Just to call attention to a few things, all of these stations here with an R on them, these are Russian stations, and this is right smack in the middle of the Australian claim. Australia is not happy about that, but this was an apolitical effort and they had agreed to participate, so they had to follow the rules. And also notice stations on the Antarctic Peninsula area are practically on top of each other. And of course, that's where those conflicting claims were, so no surprise. This map shows the 7 separate science stations that would be established by the United States. So in order to be ready to begin the IGY in July of 1957, they had to be down there building the first ones 2 years prior. So in the summer of 1955-56, there would be 2 stations built for the IGY. One here called McMurdo Station, the edge here of the Ross Ice Shelf on Ross Island. And it was really supposed to be an air operations facility rather than doing science, because their job in the first year was to get everything ready to build a station at the geographic South Pole the following year. No one had ever done that in the interior before. And then simultaneous with McMurdo Station would be the establishment of Little America, which will become the science flagship station during the IGY. But again, its first year's job was to get everything ready to go inland to build a station to be named for Richard Byrd. And then the second year, those 2 interior stations, plus 3 others that were added late in the planning. Hallett here at the bottom was intended really to be the home of an emergency airstrip. Airplanes coming from New Zealand with supplies or people or whatever were often flying on fumes by the time they got to McMurdo. So if there was bad weather or something, having an emergency airstrip was just a little reassurance. But Hallett Station also was the only IGY station that was operated bilaterally, and we shared that one with New Zealand. Very happy partnership. Moving around, we have Wilkes Station here. Remember, I was talking about the Russian stations, which are in this general vicinity, so it was probably not a coincidence that we wanted to be close enough to have a look, although we're talking a few hundred miles distance. And then way over on the other side, the last station, called Ellsworth, for another American explorer, is unique because it's the only one that's going to be supported and supplied from South America rather than from New Zealand. And again, it is just crowding this area where all of the claimant conflict countries are. So there could not have been a US IGY program in Antarctica had it not been for the United States Navy. They were the only institution that we had that had the equipment, the experience, the expertise to provide all of the logistical as well as operational support that would be required. Admiral George Dufek was put in charge, and he named his task force Operation Deep Freeze, and he numbered them by year. So we here are standing on the deck of the USS Glacier, which was the newest and most powerful of our icebreakers. And this is in December of 1955. So just the very beginning of our efforts. And notice between the ropes here that the Glacier is leading a convoy of ships through the ice, which is breaking up now because of the summer season. One of the really cool things that Admiral Dufek did was to bring along 2 artists to help document the extraordinary historic moment that was happening at this time, as well as lots and lots of Navy photographers. But this painting is the work of a Navy commander named Standish Backus. And he is showing us the icebreaker East Wind, and it's pulling along a smaller boat that's called an oiler, a yard oiler, and it's full of fuel. And they're going to take that smaller boat, deliberately freeze it into the ice at McMurdo, and call it an instant fuel farm. And it's going to keep them warm and operational for that year. And a helicopter is overhead, helping them find and spot leads or openings through the ice, which is breaking up. It really does look like broken china when the ice breaks up, but definitely not with patterns on it. This was the era of abstract expressionism in American art, and he's a good example. Well, once they get to Antarctica, now it's time for the Navy Seabees, the construction battalions. This one is Mobile Construction Battalion Special. And they quickly set up a tent camp surrounding the wooden storage hut that was built by Scott back in his 1902 expedition. So they're very aware of the history and of their own moment. But tents aren't comfortable and certainly not efficient and to work from. And so the Seabees immediately begin to build what they call their permanent settlement, which permanent meant lasting the 2 years of the IGY. And we'll see more that looks like this, but just take a look at the trash around. The Seabees could do anything and fast, but they weren't necessarily picking up after themselves. Oops. I said that McMurdo's job was to provide a station, build a station at the South Pole the next year. Well, the South Pole is at an elevation of 9,300 feet. That's almost 2 miles. McMurdo is more or less sea level. And in between there are the Transantarctic Mountains that are 15,000, 16,000 feet in height. So the only way within the time and the resources available to build a station at the pole would be by airdrop. And so everything that had to go to the South Pole had to first come by ship to McMurdo, then be reorganized over the winter, and then come spring, pack it into cargo vessels to fly to the pole. Well, the Navy didn't have the adequate aircraft, and so Admiral Dufek borrows from the Air Force planes like this C-124, or they were called Globemasters. But the Globemasters were wheeled aircraft, which meant they needed to have a flat and sturdy surface to land and take off from. And there was no place at McMurdo to build an airstrip except on the winter sea ice in front of the station. Well, that meant they had to plow the snow off of that ice, which was many feet thick. And but they had one larger tractor, but mostly it was the cleanup of it was done by these little D2s. But remember, the winters are dark and it's cold. McMurdo got to be about almost 70 below zero Fahrenheit that year. So it was not an easy job, but they did it. Here is the strip. And after many tries, the station is back here. So just for orientation. So I'm going to leave it there for a minute, because simultaneously to all of this happening at McMurdo Station, there's another one going up at Little America. And here we see Robert Charles Hahn, the civilian artist that came south that first year. And he is showing us in a very different kind of artistic style the mooring of the cargo ship Arneb to the sea ice. And he's showing us how the offloading is taking place, which in itself is just interesting, but it was hurried and chaotic because that sea ice could go out at any moment. And in fact, it did within days. I'm not sure you can see it, but the ice shelf where the station is going to be situated is way back here. And finally, he's showing us how to build a station. First thing, the CBs would level the area and then put down just a whole row of trusses to hold the building away from the snow so it doesn't melt what's under it and crumble the building in the process. But the building, they called them huts. Every one was built entirely of these 4x8 sheets of plywood, double thickness with insulation between. The edges are flanged in a way so that they fit together and then would be fastened with clips, not nails, which are very difficult to deal with either heavy mitts or frozen fingers. So first they start with the floor panels, the wall panels, trusses to hold up the roof, and then the roof panels as well. They're international orange on the outside to be seen against the white snow. And I mentioned that that Little America's job that first winter, Deep Freeze 1, would be to prepare to establish a bird station in Deep Freeze 2. And that's going to be done by tractor train. And so here now it's light again, and we see the train heading off from Little America with not only the wall panels aboard, but everything that they're going to need for life for a year at the inland station. Unfortunately, where the snow from the plateau that they're going up on the interior When it meets the horizontal snow of the Ross Ice Shelf, there's going to be a lot of disturbed ice where that transition zone is. And in fact, it was about 7 miles of very disturbed snow and ice, and including potentially deadly crevasses like this one, which would have to be blasted open and, well, first found, blasted open, and then filled in and packed down so that they could make a safe trail. So now we are talking about the South Pole again in deep freeze 2. And yes, everything is going to be airdropped except the people, the construction and maintenance crews, as well as the scientists, but also the delicate scientific equipment. So that meant we had to land airplanes at the South Pole. And it had not been done. Nobody knew if it could be done. They knew that at that elevation, there'd be very little air. You know, it's thin, and the temperature is going to be cold. Well, it was 58 below on this October 31st, 1956 landing. You know, the pilot said to me, you know, it's not a problem to land the plane. If you fix the flaps, you're going to do that. But getting off again, that's another matter. And indeed, it took 16 JATO bottles, jet-assisted takeoff, before this airplane could limp back into the air. But they had proved that it could be done. That's Admiral Dufek there standing in front of the tail there. And a few weeks later, here comes the advanced construction party. And then here come the first of the airdrops, although we see trusses have already been dropped. But what has happened is that the winter before at McMurdo, the Seabees realized that those trusses were just too long to fit out of the drop well of the Globemaster. So they had to laboriously cut them in half, drill holes, provide splice plates so they could bolt them back together again out in the cold of the South Pole. Here's South Pole Station, almost finished. Left to be done are to fill these wooden frameworks to cover them with first chicken wire and then burlap, and those will become tunnels for storing things like fuel, but also provide a way to go from one place to another without going outside. It did get to 100.2 degrees below zero that first winter. Quickly at the other 3 stations, well, at all of the stations, there were unique problems. And at Hallett Station, the problem was right in front. They were greeted when they got there by about a couple of 100,000 Adelie penguins who were nesting. Well, the Seabees and the scientists wanted that piece of land, so they simply moved the penguins. They found that if they picked up the babies, the parents would follow. But we couldn't do that today. It would be expressly prohibited. Wilkes Station was unique because in the summertime, it's bare bedrock. 98% of Antarctica is covered by ice, but there are a few places like this which are open a part of the year. It's right on the seacoast, and it is it's right on the Antarctic Circle, which means it's much farther north. They called it the banana belt of Antarctica. but they didn't have the long winter nights and the extreme cold. What they did have was extreme winds that were unbelievable. And the problem for Ellsworth Station was simply getting there. They had to negotiate the Weddell Sea, which, and in fact, not far from where Shackleton's ship, the Endurance, was crushed and sunk in 1915. And indeed, these ships were beset for weeks and days at a time. What happens is, because of the way the winds and the currents and the shape of the Antarctic Peninsula, the way they interact, they've set up a gigantic circular motion, a gyre, that keeps the summer melting from escaping and floating north, and the ice would normally melt. But instead, it's just forced around in a circle and into itself, and it becomes very hummocky and very dangerous. Well, they're there for science. And back in the planning stages, these were the sciences that were on the list for Antarctica. Meteorology topped every list. Obviously, understanding the weather was vital just to stay alive in Antarctica. Certainly also for going anywhere while you're there. But the scientists also wanted to understand better how that huge heat sink of the continent affected at least southern hemisphere weather, if not farther north than that. So about half the budget and half the personnel would be devoted to meteorology. The next four, the Aurora, cosmic rays, geomagnetism, and ionospheric physics, these were all interrelated sciences that were all dependent on the disturbances of the sun. And the timing of the IGY was because they were expecting major solar activity, and it turned out to be record enormous. And then the glaciologists and seismologists are looking beneath their feet to try to understand the ice itself, all about it and how deep it was and what was under it and so on. Oh, yeah. I don't know if you noticed, but I sure did at the beginning. How come there's no geology on this list? What's more geophysical than geology? Well, in truth, the planners said, nope, we're not going to study this, because everybody was afraid that if someone found a valuable mineral resource in Antarctica, it would set off a gold rush, as they called it, and that would just destroy the whole tenor of the IGY. And of course, everybody was afraid that someone else might find it before they did. So they just said, we won't do that. Well, in point of fact, many, many of the young researchers were trained in geology, and you can be sure they were looking at every rock they could find. So just a few illustrations. Every day at every station, twice a day, the meteorologists launched a weather balloon. They wanted to study changes in the temperature, the humidity, the air pressure, the wind speed and direction as the balloon ascended. And the instrumentation that would send those signals back by radio are all in this little box here that is attached to the balloon. Well, the balloon had to be lighter than air, of course, to ascend. And in the 1950s in Antarctica, that meant they had to fill them with hydrogen gas that would be manufactured on site twice a day. So we know that, of course, hydrogen is horribly explosive and combustible. But interestingly, I don't know of any accident that occurred at the time. Today, they just haul in big containers of helium, but they managed it. This is a recording, a film recording from studies of the ionosphere. Radio signals that are sent from a distant place are bounced off of layers of the ionosphere. And if the conditions are right, then shortwave radio communication is possible. And so they were trying to anticipate as well as understand how that all worked. And because everybody on the ice was eager to be able to talk with somebody back home, at least occasionally. I really am showing you this film strip just because it is so terribly primitive. And yet, I mean, those puffs are where the reflections take place. But at the time, of course, that was state of the art. And this is a film of the minute by minute photographing of the Aurora Australis at the South Pole. You can see here that they use the 24-hour clock, so we're talking just before midnight. But notice the changes, how fast the appearance of the Aurora changes in time. It would be wonderful to have this in color, of course, because they're sometimes wondrously colored. Every station that was on deep ice or could have access to it would send their glaciologists and anybody who would help them to dig a deep pit in the cold of the winter because they could basically study the history and as well as the chemistry and the composition of the ice as they dug deeper. It turns out that in Antarctica, in the summertime, there's just a little bit of melting, the very top layer of the snow. And then if there's new snow coming the next year, when it refreezes, it looks a little bit different. So as they descended into this pit, they could count the years rather like tree rings. And so, you know, they would get down deep enough to say, oh, here is where the Industrial Revolution began, because we see dirt in the layers, even though those factories were thousands of miles away. It's quite extraordinary. They could tell when the atomic age began by finding you know, isotopes of the radioactive materials and so on. The big glamour job of the IGY was sending out tractor parties on over snow traverses. And this map shows all of the traverses of all of the different countries that did them over 3 summer seasons in Antarctica from 1955, 56 through 57, 58, which is quite a remarkable coverage considering the methods of travel. US scientists, glaciologists, and seismologists did their traversing in snowcats like this one, tracked vehicles. They not only their motive power, but this is where their laboratories were inside, powered by banks and banks of heavy batteries. They could sleep in the snowcat as well if they chose. In front, that kludgy looking device is a crevasse detector. operating on differing electrical signals, but in the dry ice of Antarctica, it didn't work very well. They were supposed to tell if the ice beneath those pans was thick enough to support all that weight that was following. And in the back, the snowcats all pulled a sled with clothing, food, extra batteries, some fuel. But the one thing they couldn't get enough of to take with them was fuel, simply because those big snowcats gobbled up 2.5 gallons per mile traveled. So here we see the Ellsworth Traverse Party being resupplied with fuel by that small single engine otter. And it was fun for everybody because it was an adventure, and the people out in the field would undoubtedly get some nice fresh bread and maybe even mail on those flights. And here the scientists are doing their work. They travel for a day and then stop for a day and just do their scientific efforts. And just to point out, the fellow on the left is taking the data that the others are working on. That data would eventually go to world data centers where every scientist's data would eventually end up, and that information would be accessible by any researcher anywhere in the world. And those data centers are still in operation. It's quite remarkable. Well, I hope I've made this pretty exciting, because the scientists were just thrilled with what they were learning, because everything was new. They just wanted to go more, because they said, we can't stop after 1.5 years with this, we're just beginning. Well, the Navy was not eager. After all, this was not their typical mission, and their only interest was in mineral resources, and nobody knew where they were. And so they were not too pleased, although let's just say that the Navy stuck with it. Operation Deep Freeze lasted for 44 years. Well, meanwhile, back then, the State Department diplomats were very supportive of continuing this effort, because, hey, this was peaceful learning. What's not to like in this dangerous world? But their first thought was, well, if this is going to continue after the IGY, we have to have a claim. We don't have a territorial claim. But they didn't know where to put it, because, you know, there was only that one small area that wasn't already claimed. And if we put one somewhere else, we're stepping on a friendly nation's toes. This is tricky stuff. Finally, thinking outside the box, the leaders began asking, why do we need to own this place? What if we could just go anywhere? What if anybody could just go anywhere? We're here to do science. And so that was the epiphany of the moment. And in order to continue after the IGY, well, the answer then would have to be a treaty. But the issue was, okay, if nobody owns Antarctica, a treaty with whom? Well, the story of the Antarctic Treaty is another lecture, and I'd be happy to do that. But let me just say that in the end, the 12 countries that cared enough about Antarctica to invest in science stations there and their people, those would be the 12 signatory parties to the Antarctic Treaty. Well, it was no easy thing. It took 1.5 years of tedious, lengthy informal, secret talks. I stress the secret because I've become impressed with the utility of being able to speak freely when you are afraid not to. But finally, on December 1st, 1959, here in Washington, the Antarctic Treaty was signed. And it's a short treaty, and it misses a lot of things, but I just want to call attention to a bit of it. First of all, the first articles. Article 1, Antarctica shall be used for peaceful purposes only. Article 2, freedom of scientific investigation as practiced during the IGY shall continue. Article 3, that scientific investigation shall go forward with international cooperation and collaboration. Basically, the treaty enshrines and continues the IGY. Well, just to pick up where I was talking before, what about those territorial claims? That was the deal breaker issue. Nobody wanted to give up their claims. But how to deal with that? Well, again, the idea was to legally freeze the claims for the duration of the treaty. So the treaty says that you can't enlarge a claim or destroy one or change it in any way. We'll just simply put them over there so we can go forward on the things we can agree on. Finally, reluctantly, the claimant countries agreed to this. They still claim their claims, but you don't see those lines on the Antarctic map anymore because they are legally frozen for now. So the treaty was supposed to, well, it was written to last for 30 years, after which anybody could challenge it. Early drafts were for 10 years. Well, it's now more than 60 years since the treaty was signed and gone into effect. So the IGY in Antarctica never ended. It continues today. And I consider that a political miracle. So thank you. I'm sorry if I've gone long. It was a little peculiar because I can't hear any of you, but thank you.
Have them call you on your phone for questions.
Yep.
If Jonas, if you could call me on my telephone, I can answer questions if there are any.
Well, thank you everyone very much for joining us. I'll call and ask a few quick questions, but I wanted to say thank you all for joining us while we're here. Thank you. And I'll make sure everyone gets the recording afterwards. There were a few quick questions I'll ask now from the chat.
Okay.
One was an interesting one. Does tourism have an effect on the continent?
Tourism?
Yeah.
Is that what you, yes. Well, indeed, that's an interesting question because it's one of the issues that was never raised in the Antarctic Treaty because in the late 1950s, nobody thought about that yet. But by the mid 60s, there were some tourist ships that started to go to Antarctica. And today it's a big deal. As we know, a lot of people go there. And the treaty has been amended a few times, but also the tourist industry has been able to participate in some of the annual treaty meetings that take place now because both sides want to keep the continent pristine. And so there have been accommodations, but at the time of the treaty and at the time of the IGY, it was just, nobody'd heard of it.
Great, thank you. Do you see the IGY as a precursor to the Paris Climate Accords and other similar climate change agreements?
Whoa, probably. You could make that argument. I can't say that I have noodled on that a lot, but of course, you know, this was a huge international undertaking. And yeah, the climate accords are a huge international undertaking. And indeed, they're dealing with the same issues because, well, in fact, Antarctic ice is critical to the future of the world. I like to say to people, well, the ice on Antarctica is always in motion, coming from the high elevations down farther, you know, to the coast. But in the West, what's called West Antarctica, in the direction of the peninsula, that ice is grounded below sea level. And if it starts moving, and it is under the Thwaites Glacier, if that should go, well, I just say to people, Maryland and Virginia will be smaller states because of sea level rise. So yes, they're all very connected, and we need to pay attention.
Thank you very much. I'll ask one last question because I think it's an excellent one to finish on. In what capacity did you yourself go to the pole, and how did you get there?
Well, I went there in my capacity as the historian writing the book. In fact, I had not put into my proposal, which I was invited to present to NSF, I didn't put in there that I wanted to go because well, for two reasons. You can't just call up United Airlines and say, I want to go to McMurdo, because that's not how it's done. But I also knew that Antarctica was for science, and I'm a historian, and I didn't have any idea what it would cost, because, you know, how would I find out? And I would just price myself out of the market. So it was actually my friends in the Navy who got this project started. They wanted their stories remembered. And they went to NSF and said, we think Diane ought to go to Antarctica. And so I did get to go. And I went by way of the support company out of Denver planned it. But I took commercial aircraft to Christchurch, New Zealand, which is the jumping off point for Antarctica. And then I took an Air National Guard LC-130 Hercules airplane to McMurdo. I said that the Navy ran Operation Deep Freeze for 44 years. In 1999, they disestablished is the word, and the job was taken over by the Air National Guard of the Air Force out of they're headquartered in Scotia, New York. And so that was the aircraft, and it is a cargo plane. We were in webbed seats along the edges of the plane. Well, it's an experience. It was an 8-hour flight. And then when I went to the South Pole, that was just part of my education. And NSF allowed it. I was, and the NSF representative at the South Pole, a fellow named Jerry Marty, who has become a dear friend. He really was working hard to make sure that that happened. So I was able to fly to the South Pole again on a Hercules, actually most of that time in the cockpit, which was a thrill. I took this photograph from the cockpit of that plane flying over the transantarctic mountains. And planes still do not stay at the pole because it's so cold that they have to keep the engines running, and by the time they unload and reload with whatever's going in each direction, they're gone. So I actually came back on a different plane, the same type, but and I was only there for several hours. So but thank you. That was a wonderful question. It's a fun to talk about. Thank you.
Yeah, I think that's fascinating. I just say thank you very much.
Well, thank you for having me. It's you can tell I kind of like to share the story. Thank you.
Thank you, and thank you everyone for coming.